I stop the sharings. How to stop this one? Let me share my PowerPoint slide. Okay. Okay. So last time where we stopped? I think we stopped here. Okay. So just wondering, can you solve this for the example form? Can you give me the answer for the value of z? I think it's for a z, a value of z as well as a v. Okay, what is the answer? Anyone? You can write in the checkbox. Okay, so here if you look at here, right, it's similar like a previous example. Okay, what you have to do is you have to you determine the TC, right? Because it's given the temperature and also pressure, PC, right? And from table 3.1, I think you can get sigma, epsilon, okay, mu, okay, I don't know what is it called, and then alpha TR, okay, alpha TR. As well as do not forget to find the omega from appendix B and calculate TR as well as PR. Okay, TR and PR. So here you can get, okay, I just focus on a radicon, okay, and then you have to calculate Z. Since last time you determined this is what is it, the gas phase, okay, gas phase, okay, so Z naught is equal to 0, okay, additional Z, okay, and then you have to calculate by using Z equal to 1 plus beta minus Q, okay, beta, okay, Z, Z minus beta, right, divided by Z plus omega beta, okay, Z plus alpha beta, sigma, sigma beta, okay. So for the liquons, the value of epsilon is equal to 0, okay, so equal to 0. So you can calculate, okay, and then you can get Z, the final Z is equal to 1, okay. From this one, just substitute into V equal to Z RT divided by RP. So you can get value of Z in cubic centimeter per mole. Okay, any answer from you? Afika Siddiq, what is the answer? Have you calculate from this one? Previous class I told you to uh solve it, right? Okay. Anyone? Afika, ada tak situ Afika?
Ya, Doktor.
Ada jawapan.
Z saya dapat 0.9278.
Okay, 0 0.928, and then for V
V 1915.6.
1.5. Okay, so this is the answer. Okay, boleh ya? So that is the answer. Okay, for B and C, similar. Only the difference, if you look at there, that um, alpha, they have a omega, right? So this is why we use the omega. As I told you, there is a deviation for other components. Okay, is deviate from the line of the argon, krypton, and also xenon. Is in significantly deviate. Okay. So we cannot use radicon actually. Okay, if you look at here, the the component of the gas is actually is ethylene. So meaning that if you want to get a more accurate answer, you have to calculate by soft radicon as well as Penn-Robinson. Okay, so if you look at here that just refer to the previous table, right? This one. Okay, so only what you have to replace is the value of where is this one? This one, right? Okay, these two parameters with this one. Okay, so meaning that for alpha TR you have to substitute with this parameter. Okay, and the value of omega you can determine from the appendix B. Okay, you have to remember if Penn-Robinson you replace with this parameter for Penn-Robinson. And this one, I think subradicon is similar. Okay, for this parameter, except for Penn-Robinson is difference. Okay, okay. Anyone solve this one? Have you solved for the B and also C? What is the answer? Ada siapa-siapa? Afiqah ada ni buat juga B dengan C. Tak ada. Afiqah ada buat B dengan C.
Tak.
Tak. Okay, tak apa. Okay, so for B, if you do the calculations, okay, this one's Z is equal to 0. This thing is 0.928. This one Z and V equal to 1918. Oh, not really difference from the radical. Okay. And Penn-Robinson, if you look at here, that 0.292 Z and V is equal to 1900.6 formula. Okay, this is the answer. Okay, so you can try at home. Okay, how to calculate by using a Safradicon and Penn-Robinson. So that is the answer lah. I hope that you can get this answer. Okay, this two. Okay, so it's almost slightly different lah between Radicon question. I think because of the lower temperature and just a moderate, how to say, just a moderate pressure, right? Okay. So actually for this condition, you can use also, what is it? A real equation. Okay. Because it's just a 12 bar. So doesn't mean you can, it's a, I think the value is going to be almost similar if you use the variable. Okay. Okay. And this one is tutorial 2, just similarly as a example 4. I don't think I will as it show to you the solutions. The step is similar, the procedure is similar, but only the different temperature. Okay, 50 degrees C and 15 bar. Just replace like this one, the previous one, right? With the 50 degrees C and also 15 bar. So you will get the answer. Okay, but the most thing I think you have to make sure whether it's gas phase or liquid phase. Okay, that is the most important before you decide for the calculation. Okay, any question about the tutorials before we proceed with another method, which is uh, what we call it as a generalized correlation. Okay, so for generalized correlation for gas and liquid, the most important thing is we have to use a interpolation or extrapolation from the table in appendix. Okay, that is the most important thing. But if we compare between cubic equation of state, virials, okay, and also generalized correlations, the generalized correlation you don't need to do the, I think you don't have to do the iteration. Okay. Not exactly you have to do the iteration because you already do the interpolation to determine the compressive factor Z naught and also Z prime, as well as the parameter for the virials. Okay, you can directly just substitute the value into B prime and also B naught, so that you can get the, you just substitute to the equation, you can get the answer lah for for the, by using a PV equal to ZRT. Okay. Okay, any questions? Okay. So I guess no question from all of you. I think we can finish. I think if today we will do a more tutorial. I think we have some tutorials. Okay, tutorial. Okay, let me explain for this one. Okay. Okay. So for today I will do a generalized correction for the gas and also generalized correction for liquid. So for gases, if you look at here that we have to determine Z total. I can say is a Z total, and also because Z naught and also Z prime you have to determine from the tables. Okay, once you determine Z naught and Z prime, okay, so you can get Z totals. Okay, so this is how to say Z equal to Z naught plus omega Z prime. Okay, so I will explain the composite factor first, and then we move to the virial equation. Uh, Actually, it's like for virial, it's like an extension from the previous equations, because previous equations the value of B and also C actually is it's quite, how to say, we have, you have to determine from the handbook, right? But for this one, it's already available in the this main textbook. Uh, you can use it. Okay, just substitute with the value, some value for the equation for B. Okay, and then you can calculate. Okay. Okay, so this is the correlations for the compressibility factor. We call it as a pizza correlation. Okay, we call it also pizza. Z equal to Z naught plus omega Z, Z prime. So where you can get Z naught and also Z prime, if you have a main textbooks, just please refer to table E1 to E4. Okay, I'm not sure for the new books. I don't have that book. I think still for in my office. So just referring to table E1 to E4. Okay, in appendix, why appendix F? Appendix E. Okay, it should be appendix E. I think for the new book is appendix F. I'm not sure, but just determine this one. Okay, table E1 or F1, value of Z naught, the title and value Z prime or Z1 here. Okay, so you have to remember that this equation is only for the slightly polar or non-polar, like a hydrocarbon. Okay, for highly polar is a larger error. You have to use a different equation actually. Okay, for the highly polar component. Okay, for the slightly polar, the error is below than 2 to 3%. Eh? It's only for like a hydrocarbon, something like there is no official. Okay. Okay. And if omega equal to 0, meaning that is a simple fluid, like xenon, krypton, and argon, is a we can use just Z equal to Z naught because the value of Z prime is very small. Okay. Okay. How to use this equation? Okay. If you look at here that this is the relationship. We call it Kessler, only Kessler, or just also pizza, same. Okay. So if you calculate the TR, this one is from the table. If you calculate PR and TR, okay, you can get Z naught from it. But mostly, most of student, or the easiest way is just referring to the table E1. Okay, if you determine the TR here and also PR, you can read directly from this one, from this diagram. Okay, for example, if you calculate and the value of PR is 1.4, right? Okay, and then the value is 1.2 for TR. So you can approximately to determine the value of Z naught. Okay, it's just a relationship between TR and also PR. Okay, but another way you can refer to the table A1. Okay, that is the easiest way. If the value is not available, you have to do the interpolation between the value. Okay, TR and also PR. Okay, so you have to remember that. Okay, this one is to determine the value that Z naught is actually is not really accurate because you have to read directly from the figure, right? Okay. Okay. So this one I think what is the title? Quantum gas, hydrogen and also helium, neon, right? So generally we have to calculate TC, PC and also VC. Okay. Um, this is only applicable for hydrogen, helium, and also neon. Okay, you have a value for the from the table, right? Okay, uh, that one is for the certain temperature. Okay, so in case for the hydrogen, okay, also neon and also heliums, we can use this equation also. Okay, to get the accurate TC and also PC. Okay, this one in case for the hydrogen actually. Okay, so not really for the hydrogen and also neon, but mostly you can just refer to the appendix table B1. Okay, so you just substitute the particular temperature and then you can get TC, PC and also VC. There's a special equation, okay, for hydrogen, helium and also neon. Okay, but in case for you, you can use just directly from the table B1. Okay. Okay, so this is for the compressibility factor. Okay, another one is a pizza correlation for the B. This one is more on the virial equations. Okay, Z plus BP divided by RT, right? So this is a two term. Okay, two term. Okay, so since they use a two term, please remember, okay, this one is only applicable for low to moderate. You cannot use for the high temperature, high pressure. Okay, you have to use the Lee Kessler if you want to use at high pressure. Okay, moderate to high. So if you look at here that once you expand these equations, okay, it's become like Z equal to Z naught plus omega Z prime, right? Okay, so only this one you replace with the B naught and also B prime, and this one PRTR, PRTR. Okay, it's a simple and recommended. So for me, okay, if you're asking me if the temperature is low to moderate, I'm not gonna use the Rodriguez or Raycron or Per Robinson, or as well as I will not use the Lee Kessler. Okay, I will use this one. It's a very simple. Just substitute the value of B naught, B prime, PR, and TR, and you can calculate the compressibility factor. Okay. So if you look at here, simple and recommended. You have to remember for non-polar, only for non-polar. Meaning that for hydrocarbon. Okay, something like not have a OH, cannot very high polar. Okay, there appears to be no limitation on the P. Okay, so this is just a derivation to get the B naught. Okay, since the value of B naught and B prime we couldn't find, it's not given. Okay, so we expand this equation and you can get this one. This one. That's why it's simple and recommended. You just calculate TR and PR. Okay, so once you calculate TR and PR, right, just substitute TR and PR and you can get B prime and also B naught. And this prime B naught you just substitute into Z equation. Okay, so you can directly calculate Z, the total Z lah, the compression factor. Okay, and then you by using a PV equal to ZRT can calculate. Okay, so this is the the easiest way. If the condition is low to moderate pressure. Okay. So if you look at here that only you can use if you get the how to say the TRPR is within this region. Okay. This one you can use varial. If more than this one, more this region, this is we consider as outside of the region. You cannot use the varial. Okay. The one that highlighted in the with the red color. Okay. So this is what you have to consider. Okay. So even actually you cannot just simply observe the pressure, right? Okay, if 15 bar, we still consider that is a moderate pressure. But if 20 or 50 bar is already high pressure. Okay, you cannot use the radial. Okay. Okay, that is in case for the what is it? Lee Kessler and also virial equation. Okay. Uh, as I recommended, low to moderate, why you just use a virial equation. Okay. So what is the validity of the ideal gas equation you can use? Okay. So as I told you previously, you can consider z equal to 1 when you referring to this figure. If you look at here that the value of z naught and also z naught should be 1.02. This is equal to z. Okay, because it's lie on this line. This is you can use if you calculate TR and PR and the value is in this on this line, okay, between 0.98 to 1.02. So we can consider that is the ideal gas. It is reasonable. Okay, if more than that, we cannot consider as a ideal gas. Okay, and you cannot use that ideal gas equation. Okay, understand? Okay, any question about the gases before we proceed to the liquid? And then we will do the tutorial together. Don't have to worry. Any questions? Okay, tak ada soalan ya? Okay. So let's see the generalized correlation for the liquid. Okay. Is it too fast? I hope that uh, you can know lah what I say or this just for me for this chapter is you just use that equation, okay, and see the condition of the system, whether liquid or gas. Okay, but this is the basis before we proceed with the for the next chapter. Okay, especially seeing the phase of the system and the liquid, gas, or two-phase system. Okay. Okay. So let's we move to generalized correlation for the liquid. Okay. Actually, they have a special equation. Okay, for the liquid. For the liquid is have a special because once you use if you want to calculate the volume, isn't it, at the liquid by using gas equations, actually is not really accurate. Still can use for the approximations for the prediction, but the value is going to be not really accurate. Okay, that's why we introduce new equations, okay, special for the liquid or at the saturated liquid. Okay, because if you use a cubic equation of state, it's going to be low accuracy. Okay, um as well as if you use what is it what is it, Lee Kessler, right, is only suitable for the non-polar and slightly polar fluids. Okay, so that's why it's not really applicable for the liquid phase. Okay, so if you look at here that a molar volume of saturated liquid, yeah, that one generalized cubic equation of state, a low accuracy for the liquid. It's only for the vapor phase. Lee Kessler correlations include data for the subcooled liquid. Actually, it's only suitable for the non-polar and slightly polar. Okay, if you want to calculate the volume of the saturated liquid, we call it as a Racket equation. You have to remember, this is a Racket equation. Always tell a student for the liquid, if you want to calculate the volume, you have to use the Racket equation. Okay. Similarly, the data that you required is from the appendix B. Okay, appendix B, for example, like a VC and also ZC. If you look at that appendix B, that included the ZC and also VC, right? So you substitute into this. But the most important thing is you have to calculate TR. Yeah? And if you look at here, that the accuracy is around 1 to 2% error. Okay, so meaning that is more accurate now if you use this question. Okay, for the calculation of volumes. Okay, just substitute. Okay. And then we have generalized density correlation. Okay, this one, if you know the correlation is actually if you know initial condition and you want to calculate at the another condition, for example, condition 1 and conditions 2 lah. So we can estimate the liquid volumes, okay, by using a density, okay. This is a two parameter corresponding state. Okay. So what you have to do is you have to calculate this one, right? Rho R1 and rho R2. Rho R meaning that rho divided by rho C lah. Right. Meaning this is the density, okay. Of course, for the liquid, gonna be related with the density lah. Okay. This one. Okay, similar like TR and also PR. Okay. So how can we get this density create rho R? Okay. So in order to get the rho R, there's another method we can refer to the diagram actually. But you have to determine PR and also TR first. Okay. So once you determine PR and also TR, we can calculate a rho R. Okay. For the first condition and also second condition. And from that, we can do the correlation relationship to calculate V2, meaning that this is the condition, the volume at the final condition that you want to determine. Okay. So we only required, what is it, only experimental data. This is actually you have to determine only PR, TR, right? And you can get rho R, okay, for that condition. Okay, if you look at here, if you calculate rho PR, and then this one, right? This is 4, right? For example, you get 4. And then the value of TR, this is TR. Alamak. Okay, tak nampak lah. Okay, saya kena buat macam ni lah. Kalau tak, dia hilang dia punya mouse. Tak tahu kenapa. After I update the web back, mostly once I didn't move the cursor, is disappear the cursor. Okay, and then 0.8, right? So you can just read lah. This one. You can get value of rho R. Just substitute into the previous equation. Okay, this is for the saturated liquid. This line for the saturated liquid. Okay. Okay, that is another method that you can use. VC and also but we have to know the first condition first to use this density correlation. Okay, understand? Okay, so if you want to calculate rho R also, you can calculate VC and also V. This is if you can find what is it, VC and also V. Okay, so you can calculate rho R. We call it a density at the critical point. Okay. Okay, so there's two important thing for the generalized correlations. One is for gas and also another one is for the liquid. Okay, let's we do the tutorial together. Okay, I think this one easy, right? Okay, determine the molar volume of N-butane at 510 Kelvin and 25 bar. Okay. A, the general ideal gas equations, generalized compressive factor correlation, and generalized Beer coefficient correlation. So this one I think is this is virial, C is virial, P is Lee Kessler. Okay, this one I didn't know, you have to calculate and we can do comparison. Okay, so if you look at here, of course, at 25 bar, the ideal gas equation is not applicable because this is too high, the pressure, right? Okay, so once you calculate just V equal to RT lah, okay, you can get the answer, right? V1696.1. Okay, but if you use the generalized composite factor, you have to determine the omega. Okay, and also you have to do the interpolation. Okay, how to do the interpolations from the TR and PR? Okay, if you look at the table E, right? Value of TR is equal 1.2, right? 1.2, mana TR? STR 1.2. Okay, and PR is 0.659. 659, 1.2. This one you have to do the interpolation. Okay, between the how to do the interpolation, you have to refer to the appendix. But you learn already in the during the course of mathematics, right? Okay, but you can refer to the appendix F. Okay, the title is steam tables. Please refer to the steam tables, appendix F steam tables. Okay, I'm not sure whether appendix F for the new books or appendix G. Okay, but the title is steam tables. So there give a equation how to do the interpolation. Okay, faham eh? Ada soalan tak kat situ? So this one you can directly you can get value of the Z naught lah. Okay, and also Z prime. Okay, faham eh? Saya tak pasti. Sekejap saya share ada tak ah? Kejap What's the value? Rasa saya tak ada. Okay. So please take note. Appendix F or appendix G. Okay. So you can get Z naught and also Z prime. Okay. For the virial correlation, okay, if you look at here that you have similarly you have to calculate TR and B naught by using an equation of B naught and also B prime. Just substitute into this equation. Right. Substitute. And once you get the answer, okay, you substitute here. And this one substitute here. Don't forget that PR and TR, okay? And also omega. So you can get value of 0.879. And you get 1489. Okay. Actually, it's not really difference, right? Only how many percent is different. Okay, compare with the ideal gas. See, 1.6, right? So meaning that you cannot use the ideal gas equation. Okay, if you use virial, it is acceptable. 25 is still we can consider as a moderate. Okay, but for more accurate, you can use the composite factor Lee Kessler. Okay, faham eh? Any question about this equation? About the difference between ideal gas, composite factor, Lee Kessler, and also virial, piezo virial, and also piezo Lee Kessler. Okay. No, okay. Yes, no. So let's see this example for the gas. Okay. What pressure is generated when 1 pound mole of methane is stored in the volume of 2 cubic feet and 122 degree Fahrenheit using ideal gas equation, radical and generalized correlation. Okay. So by the using ideal gas is directly lah. You just calculate and you can get 212 4. Right. Okay. But for radical, if you look at here that this one you can use directly, right? But you can also use the equation vapor and liquid. This one is they use a directly equation from by using a P lah, to determine the value of P. Okay. So this is the polynomial. Okay, so it doesn't matter whether you want to use liquid or vapor equation or this polynomial from the Redlich form. Okay, so you can get the answer. Okay, and for the compressive factor, the problem is you have to do the iteration. Okay, why we have to do the iteration? If you look at here that we don't know the value of P, right? Okay, and how to calculate the PR. Okay, since you have to do the interpolation, right? That's the problem. Okay, since your target is to determine pressure, right? And it is given only the temperature, right? So you can calculate TR, but the problem is how to calculate PR. So from this one, okay, what you have to do, you have to do the interpolation. Okay, since PR equal to P divided by 45.4, right? From this one. So this one is from equation this one. P actually is PR equal to P divided by PC, right? This one is PC. Just determine the PC. Okay. So you can get this kind of the relationship, right? PR1 equal to P equal to 45.4 PR. Okay, equal to 212.4 Z. Okay, and then just this one, rearrange this equation. So the first thing is you have to guess the first pressure, any value. Okay, so you can guess any value from this one. Faham eh? So for example, this one you can get 4.68. Okay, and then you have to substitute. You have to do the interpolation with the TR because TR is fixed. Okay, so you have to refer to table E3 and 4, and then you have to substitute into this equation Z and Z naught. I mean you have to determine Z and Z naught, and you calculate this value of Z naught plus omega Z prime, and you can get Z. Okay, this value Z you substitute again to this equation. Okay, to get the value of PR. Okay, this is a new PR. Okay, so when you get the new PR2, do interpolation with TR. Okay, referring to table E3 and E4, you will get new Z0 and also Z1. Meaning that you have to do the interpolation until it conversion. Okay, so since this is the final PR and also Z0, okay, so you can get 189.0 ATM. Okay, if we do the comparisons, okay, this one is 187 or 189, almost similar, right? This one, the Lee Kessler and also with the Redlich equation. If you compare with ideal, is really the error is really big. Okay, so we cannot use this ideal equation. Okay, because the pressure is what is it? The pressure is different, right? 187 atm is a really really large pressure. Okay, faham eh? Okay, so that is how you do the iteration to determine the pressure by using composite factor correlation. Okay, and then another examples. This is we're gonna use a video. Okay, if you look at here that by using ideal gas, the mass of 500 gram of gas ammonia is contained 3000 cubic centimeter vessels immersed in the constant temperature but 65 degrees C. Okay, calculate the pressure of the gas. First ideal gas and also generalized correlations. Generalized correlation, if you look at here that the pressure, temperature. Oh, we have to calculate the temperature, right? Okay, this one whether you want to use uh what is it? The Lee Kessler or Virials, you can determine PR. See, the PR is almost around 3, so you can use a Virial equation. Okay, so or you can um, use also Lee Kessler lah. Okay, it doesn't matter. Okay, but this one is the stated generalized correlation. Okay, so meaning that whether you want to use composite factor equation or virial equation. Okay, so for ideal gas, you just calculate 27.53 bar. Okay, so this one is we choose a virial lah because it's we consider as a what is it moderate. NPR is almost around 3. If we calculate from the ideal gas equation, right? This one. Okay, we can predict it's just around 3. 27.353. This one, right? If you look at here. Okay. Divide by PC. P divide by PC. Generally, if we use the approximation, right, from the what is it, from the ideal gas. Okay, so that's why we get 0.244. Okay, so it's around 3, right? So we can still consider to use a virial. Okay, if you look at the what is it, the rule or the conditions to use the virial, right? This one, on the virial. This one. Okay, around 3 PPR or TR go to 3 lah. Okay. Okay. So let's we do this together. So 303. Calculate the molar volume of saturated liquid and saturated vapor. 3. Can you use this one? Using a generalized correlation. 13.71 bar and also 15.41 bar. No need this one. This one I think you know how to use it. Only saturated liquid and saturated vapor. By using suitable generalized correlation. Can you calculate? Only for propane. For propane. For propane. Okay, Redrick Kwong. Okay, if you use Redrick Kwong, right? If you use Redrick Kwong, vapor for Redrick Kwong, okay? This one, liquid. For the liquid is 108.1. No more. Okay, and for the vapor is 1493.31. And compare with the suitable generalized correlation. Okay, okay. For liquid, what equation that you can use? Amirul Haziq. For liquid, what we can use? Amirul Haziq. Haziq ada kat situ tak? Amirul Haziq. Amirul Haziq. Amirul Haziq. Amirul Haziq tak ada. Ada. Tak ada attendance. Amirul Haziq. Megat Alimi.
Yes, okay.
What question that we can use? The suitable generalized correlation to calculate the in the liquid phase. Saturated liquid.
Is it compressible factor?
Yes lah. Which one? No. It's for liquid.
Or liquid? Wait lah.
Hmm.
For propane, right? Cannot use
Hmm. Liquid. Saturated liquid.
um
Which one?
I don't know. Okay. Is it at least Kwang
You
or just
when I teach you, you understand or not?
a little bit slow? Like sama-sama lah, faham, kadang tak.
Okay. Hang pula. Sekejap. Tiba-tiba.
Doctor, can we use Kessler? Kessler.
I told you calculation for the liquid. Okay. Eh? Jangan hilang dah lah ni benda ni. How to calculate PVT? We have equation of state. We have, what is it? Generalized correlation, right? Okay. Then question of state, we have ideal gas. We have virial. Okay. Virials can be divided into and then cubic version of state, right? Okay. The cubic version of state we divided into 4. This is all the 4 vapors and also for the vapors of for the gas or and for non-polar. We have van der Waals. This one we have Radicquang. We have SRK soft Radicquang or Radicquang soft. This one Frank Robinson. And we have vapor and we have liquid. Okay? Alright? Liquid lah. So you have to consider the whether it's liquid or vapor phase lah. Okay? The next correlation we have compressive factor and this we have a gas and also liquid. Okay? Gas we have compressive factor and also virial. Okay, for the liquid we have, what is it? Okay. Biru pula. Boleh lah biru. Liquid kan. Okay. Kita ada apa ni? Record equation. Kita ada yang row tu. Density tu. Row. Saya buat row lah. Row. Macam mana buat row? Okay. Faham tak? Okay. So from the tutorials, instead you have to calculate liquid by using a suitable generalized. Yang mana awak kena guna? Which one we have to use? Siapa tadi? Megat eh? Megat? Which one we have to use?
Racket kot.
Racket eh?
Racket.
Can you see the clear picture of this one? The summary?
Yeah. I
Ah.
think
You
Okay,
nak
okay.
calculate, you want to calculate. This one is more to like a polynomial. This is we call it polynomial. This one you have to calculate z. Okay, and then you have to use this one. PV equal to ZRT. Okay, this one is yang ni sama lah, PV equal to. Yang ni memang dah sama je, PV equal to. This is just an expansion of the what is it? PV equal to ZRT equation. You have to determine Z and substitute into PV equal to ZRT. This one also similar. Okay, so you have to use record. Okay, V equal to, please calculate Z, VC, ZRT, ZC. I think you can do this one lah, like this summary lah. Okay, you can write down on your what is it? OneNotes, right? Summary, and also you can maybe write in your iPad. Okay. 1 minus TR. Okay, power of mana kosong. Power of 2.857. Okay, calculate V. Calculate V for liquid. Okay. And then it stated also you have to calculate at the saturated vapor condition. Okay. Since if you look at there, the condition, okay, for the pressure and temperature, what equation that you can suggest to calculate by using a generalized correlation equations? Anyone? Haris? Muhammad Haris? Muhammad Haris? Haris? What equation that we can use?
For yang mana?
Saturated vapor.
Saturated vapor.
Since just now Megat said by for the saturated liquid, for the liquid phase, we have to use record. But there's another condition also, which is stated you have to calculate at the saturated vapor, okay, vapor phase lah. So what equation that you use from the generalized correlation equation? Which one you want to suggest?
Pakai yang row tu boleh ke?
Yang mana?
Yang row.
Row, yelah row. Row yang mana ni row? Yang liquid?
Yang vapor lah.
Vapor ada guna row ke?
Tak, yang liquid.
Liquid. Tak, saya cakap yang vapor phase.
Vapor Oh, je.
Which one Harid? Kalau awak tengok kat sini. Vapor, which one we can use? We have a equation of state. Kan, kita ada equation state divided into ideal gas, virial, cubic equation of state, and equation of state divided into van der Waals, Radicquang, soft Radicquang, as well as Penn-Robinson. Penn-Robinson's, this one is a polynomial form, and so you can use this parameter from the cubic equation of state to calculate vapor or liquid phase by using this equation. And generalized correlation, we have a gas and also liquid. Can use Lee Kessler is compressibility factor, and also we have a virial, piezo-virial. Okay, for liquid we divided into row and also record. Okay, which equation that you can use? for the vapor phase related with the
phase.
generalized correlation. Generalized correlation.
Pakai virial ataupun yang coloration Z tu.
Okay, itu ada dua. That is a two equation. But which one is based on the condition is stated? Which one you suggest?
I suggest yang coloration yang PZ tu. Sebab dia low, dia moderate P. 13 kan?
Sure, virial. Okay. Good. It's 13, right? It's a moderate pressure. So
Ya.
please calculate. Okay, give me the answer. I will pick, I just randomly pick one name. I want to know the answer. And just now I give you the answer for the calculation by using Radicon, right? You can compare. So meaning that, Doktor, untuk vapor ke liquid dulu? Mana-mana lah. Okay. Any phase? Because you have to calculate both actually. Just substitute into the equation. If you want to calculate liquid, is a very short calculation. Both lah, liquid and also vapor. Okay, this one already okay? You already jot down this the summary. Ini the overview lah, general overview of this chapter. Alright. So this one you have to consider the pressure. This one also pressure. Okay. Please calculate liquid and then vapor. So if you look at here, 13.71 bar, it's just a low to moderate pressure. Okay. Anyone give me the answer? That's the answer. Liquid 10.47. Right? Are you sure? 10.47. Open. Apa saya dapat? Is it correct? Let's see for something. Akmal, how come you can get 14.47? How about Zurhani Fazrin? Zurhani Fazrin? Apa itu? Zurharni Fazrin. Ada tak situ? Nak kira. Lambatnya. Oh, liquid first. Okay. Anyone? 19.4.7. 94. Okay, 94.17. That is the answer. So you can look at the what is it? In the chat box. Okay. Li Chaoyi. Give the answer. 94.17. What's that? I calculated 94.20. It's okay. It's acceptable. 94.17. How about gas phase? Vanessa, gas phase. Any answer? This one is not foggy. Just look at the chat in the chat box. And the answer 94.17. How about gas phase, Vanessa? Vanessa Teo Zingyi. Are you there?
Dr. Quay lại.
What is the answer? Oh, let me check. 94 point, okay. Lambatnya. Patutnya cepat je tu. Dah, anyone? 1454, okay. But my answer is 1537. I'm not sure who's correct. You can confirm. Okay. So when I calculate 1537.5 cubic centimeter per month. Okay. And that is my answer. But yeah. Okay. So let's this one is okay. Later you can do lah. For and retain is similar lah. Okay. The difference is only the component and also temperature. This is 100 degree C and also 15.41 bar. Okay. Let me see which one. Example 7 lah. Why example 7 here? Oh, this one I think. This is only for liquid lah. You use a record equation and you can get the answer. This is just direct. You can how to say calculate. You can read, I think. Okay, because for this one, we want to determine the volume V2, right, at the final condition. Okay, but we have to determine the initial condition first. Okay, and then you can calculate for V2. It's just using a row equation, right? The correlation. Okay. What I want to do is for this one, look at tutorial number 5. Okay, tutorial number 5, right? This is the last tutorial for the liquid. Okay, so if you look at here, okay, tutorial number 5. The specific volume of isobutane liquid at 300 Kelvin and 4 bar is 1824. Oh, see, this is the volume, liquid volume. The liquid volume. Estimate the specific volume at 5 Kelvin and 75 bar. So meaning that you have to calculate by using what we call it as a row equation. I just call it as a row equation. Okay. So it's given T1, right? T1. Okay, V1 liquid. V1 liquid is equal to 1824. And then T1 300 Kelvin. T2 P2. 4 bar. So what you have to do is to determine V2. Okay. What is the V2? 415 Kelvin. Right. And pressure is 75 bar. Okay. 75 bar. Okay, what you have to do, you have to calculate TC, determine TC and PC, and as well as calculate TR and PR. So there is two conditions, which is TR1 and also PR1. Okay, so you have to calculate TR1 and also PR1. And another one is PR2 and also PR2. Please calculate. So once you determine this one, okay, please refer to the, alamak, saya tak boleh bawa ke belakang. Have you still remember the figure, right? For the row, right? This one, if you still remember this figure. This one is row, right? Row R. And also is this one is PR. Inside is TR. So you have to determine the value of row R. So you can get row, because we want to use the correlation, if you still remember, V2 divided by V1 equal to row V2 divided by V1 equal to row R1 equal to row R2. We want to use the equation, the correlation. Okay, so you can get value of row R1. This one we call it as row R1. Okay. And then if you look at here, for TR2 and PR2, actually is not within this region. Okay, it's not within this region. In this, actually is outside of this region. So you cannot determine directly from the figure. Okay, what figure? The previous figure. Let me check. The figure of generalized density correlations, okay, is outside of the region. Okay, because once you calculate rho R2 is equal to this one, rho R PR2 and 3.16. Okay, so we cannot use this one. How to determine rho? This one PR. Rho R. Okay. Okay, it's not available in the figure. Okay, if you do the how to say the cross horizontal and also vertical line, okay, the value of TR2 and also rho R2 actually is out of the regions. Okay, so you can calculate actually rho R2 and rho R1. Okay, not this one is not the value, actually is number of figure in the textbook, sorry. Okay, rho R2 we cannot determine this rho R2 actually. Okay, so you have to refer to the figure 3.16 figure. Yeah, this one, the figure. Okay, so it out of the region. This figure, this one. Okay, because if you calculate TR2 and PR2, I got TR 1 point something and 2.0 something. Actually, 2 point. It's here and then it's here, outside of the region, just around here. Okay, just around here. around here lah. So we cannot do the how to say the interpolation. Okay, we don't know the value except for TR1. If TR1, if you look at here, when you calculate 0. Rho R1 is equal to 0.11, right? And then the value of TR1 is equal to 0.73. This one is just around here, right? You can do the interpolation. So you can get around 2.4 something. But for the value is around here, right? Outside of the region. So how can we solve this problem? Okay, we have to rearrange the equations. Okay. Since rho R equal to rho divided by rho C divided by VC divided by V, okay, PV equal to Z RT, right? Okay, and V equal to Z RT divided by P. Okay, so just substitute into this equation. Okay, and then you can get new equation. Rho R equal to PVC divided by ZRT. Okay, so we can say that this is the new equation. Okay, so for second condition, this one too lah. Okay, so the problem is how to determine this Z. Okay, this is only for second condition, not the initial condition for TR1 and PR1. This one is only for TR2, PR2 to determine rho R2. Rho R1 you can directly determine from the figure 3.11C. Okay, the previous one that I showed, right? So this one in case for the PR2, TR2. So we have to determine rho R2. This one is rho, okay? So how to determine this Z? Definitely you have to use Lee-Kessler method. You have to determine Z naught, okay, and Z prime. And finally you have to calculate Z. Okay. So you can get Z. Okay. Once you determine Z, what you have to do, you substitute into this equation and you can calculate the value for VR2, rho R2. Okay. Okay, and then once you determine rho R2, this one, what you have to do, okay, by the equation of rho R2, once you determine rho R2, right? So by the correlations of V2 divided by V1, okay, equal to rho R1 divided by rho R2. So you can calculate V2. Okay, you can calculate V2. Okay. Boleh ya? Any questions about this tutorial number 5? The step. I give you the direction and you have to solve it. Give me the answer. Ada soalan tak? Any question for this one? Any questions about how to determine rho R2, rho R2? Any questions? How many students in my class? Clear tak? Is it clear? Doctor, we need to interpolate to find Z naught. Yes, Z naught and Z prime. You have to do the interpolation. Okay? You have to do the interpolation. Because as I told you, right, the value of TR and PR, okay, is not within this region. Not in this region actually. Dia tak ada dalam region ni lah. Okay? So what you have to do is since when you calculate TR2 and rho R2 and PR2, the value is 1.0.1.017, right? Yeah. Just slightly below this one, right? And then 2.015 is outside. We cannot calculate. We cannot find the value of rho R for second condition, the final condition. Okay? But for the initial condition, yes, you can get the value of rho R1. So how to determine rho R2? From the equation that I derived, right? Just rearrange the equations, you can get the final equation, rho R2, right, equal to P2 VC divided by Z. I just consider as Z2 lah. This one is total Z lah. Z2 RT2. So this one you have to determine Z naught as well as Z prime using this Kessler correlation. And then you can get rho R2 by this expression V2 divided by V1. V1 you can determine, right? Okay, equal to R1 and rho R2. So you can calculate V2. Any questions? Before we stop, I just give you assignment homework for your break, so you can practice. Any more questions before we stop? And the rest you can do. Just this is just a tutorial and also assignment is not from here, okay? I will give you the assignment later. I think I have. That's the assignment. Homework. Okay. Assignment. Homework. Okay, not here. Wait. Where's the assignment? Homework. Oh, okay. This one. I have. Assignment question. Okay. Okay, any questions? Yes, I cannot hear.
They told us why
Hmm?
using the what method?
What method?
Why not using the Reckitt equation?
Why not using a record?
Yeah.
Why not using a record? But first condition you have to calculate using a record, right? Isn't it? You have to determine V1 first, right?
Yes. Also,
Right.
oh,
Because your equation is this one. If you look at that. Alright. It's given already, V1. V1 is given already. Okay. Why we cannot use a record? TR and PR is outside of the region. We cannot use. Okay. But this one is a V1, right? V1 is given. How about if you calculate by using record? Is it you can get the what is the information? PC ZC, right? I think because of is outside of the region. What that is one of the reason for the second condition. Okay. Okay. Any more question? Okay, if you have no questions,